Okay, so this is the last video of this section, and this is going to be dealing with differentials and approximations. It's a similar concept to the one we've covered in the previous video, so let's just extend that. What if you have a function f of x, and we know that it's differentiable, obviously, right? So what if I were to take the differential of this? What would I get? Well, it's not that difficult to understand that we'd get f dash x, right? But let's try to re-express this. Maybe, play around with the equation. We get df of x divided by d of x equals f dash of x, right? What if I wanted to take this to the other side, right? And keep in mind that d of f of x is pretty much the same thing as d of f. It just means the same thing. It's because it's the same function, right? It could be f or f of x. Doesn't really matter. So d of f equals f dash x times dx. So I basically took it to the other side, right? So what does this mean? Well, it simply means that a small change in the function value results in a small change in the value of x, and that is related by the function or the differential of the function f, and that's basically f dash x. So what I'm saying is, like, if you have an example which says that I have fx equals cosine of x, right? Then what does the differential equal? Well, the differential has to be equal to minus sine x dx in this case, and you can interpret this as dx being an infinitesimal change in x, which results in an infinitesimal change in df, of df basically, in the value of f. So small change in x results in a small change in the value of f, the function f, right? And that's represented by this. So for cosine, this particular expression could be explained using that. And if we use this particular equation, we would understand that a small change in f could be represented by a delta as well, because the d and this delta is pretty much the same thing. That's just a notation that you need to get on board with. And f dash x naught is the threshold point that we've described in the previous videos as well, right? It's the point that we're concerned with. And delta x is replaced by dx. So it's basically the same thing. But why is it so important? Well, it's important because we talked about this equation in the previous video. This being y minus y1 being roughly equal to f dash x squared x naught x minus x naught. So this is very similar to the equation y minus y1 being roughly equal to m, which is the gradient of the line, x minus x1. So there's a lot of similarity over here. And what I'm saying is that this is what represents the point slope form of the equation of tangent line that goes through the point x naught, right? Of the line that goes through x naught and comes out at this point. So that's like the coordinate at which this is applicable. So let's try to use this analogy in another example. Suppose we have an example in which we want to approximate something. Basically want to estimate the value of 4.01 to the power 1 divided by 2. How would we go about doing this? It's very similar to the examples covered in the previous case, but we're going to be using small changes in x resulting in small changes in f, right, in this situation. So we know that basically if we take any number to the power 1 over 2, we're going to get a function, right? So let's just write the function down as x to the power 1 over 2. That's just going to make our life simpler, because we're not concerned with 4.01 at this point. We just want a general form of what represents the function, right? So at this point, if we try to take the differential, right, we get df by dx equals 1 over 2. Well, the power is going to come down, right? And x to the 1 over 2 minus 1 is going to stay as it is. And if we do a little rearranging, what do we get? 1 over 2 times, that's going to give us x to the 1 over 2. We've talked about this before. The differential of the square root, right? And this is going to give us a dx. So a small change in f is resulting in a small change in f at the same time. And this is what it's related by. And we can re-express this as something. Well, how can we re-express this? Let's just not play along with that. Let's re-express this as a delta f term, right? And we know that delta f is approximately equal to x naught to the power minus 1 over 2. Let's just bring it back to the numerator to make our life simpler. And if we express this in the particular form shown, we know that delta f has to be a subtraction of y values, right? Do we know what those y values are? Well, of course we do. we know that this function exists around 4. We know that because x0 is 4, right? Because we talked about this in the previous video as well, that we want a function that's approximately good, that gives us an approximately good result around a particular point. In this case, we can see that 4.01 is a point very, very, very close to 4. So let's just choose x0 to be equal to 4. In that case, what will the upper y value be? Well, that will turn out to be 4.01. And the lower y value will be f of 4. And this would approximately be equal to 1 over 2 times x0 to the minus 1 over 2, which is 4 to the minus 1 over 2, right? And that is multiplied by 4.01, right, minus 4. So if you were to simplify this, we are trying to find this, right, f of 4.01, and let's just take f of 4 to the other side. F of 4, we get this equation as a result. That's just 0.0. That's not really a problem. The value of 4 to the power minus 1 over 2 is simply 1 divided by 4 to the 1 over 2, which is simply 1 over 2, right? So it gives us a 1 over 4. And f of 4 just gives us 2, because we plug in a 4 here, we get the root as 2. So 2 plus half times 0.01. That gives us a 2 plus 0.01 divided by 4. What does that give us? Well, that is giving us a 0.0025. But we have a 2 on the other side as well, right? So we add that. So we get 2.0025. So essentially the idea is that the approximate value of 4.01 to the half root would give me 2.0025. And this appears to be a very good approximation if you think about it. So this is basically all that we have to do in this module. In the next video, which is going to be a comprehensive one, we are going to discuss the most recent midterm paper that came in last fall for Calculus 1. That was taught by Dr. Sultan Sial amongst other instructors. So that paper is going to be discussed in detail. So hopefully you'll be able to get as much as you can out of that particular video. So see you guys there.